the longest, like 24 hours of my life. Not really. That's over exaggerating. You guys know anybody who's had like the second vaccination shot who had an adverse effect? Adverse meaning you had like a negative reaction to it where like, yeah. My wife is going through that right now. She got her shot yesterday, her second shot. And now it's like when I was leaving for work, she was just like, yeah, I don't feel so great. I'm like, what? Yeah. Yeah. This is the beginning of it for her. So then I tell you about my son sleepwalking. Kind of. Yeah, where my son like has this like sleepwalking episodes where he like goes throughout the house having a conversation, tries to escape. Yeah, he did that again last night, and I got like no sleep. I'm literally on 4 hours of sleep. I think he is.
Does he drink milk before he goes to sleep?
No.
No?
No, just water.
Okay, because I know, like, I've heard stories where, like, dairy is a weird reason why some people sleep. Well, that's why my sister slept.
Dairy is the devil? I don't know. No, he does not. He actually is not a fan of milk. Okay. It's funny that way. Anyway, back to whichever.
My brother told me that there was a bug in my milk and I wouldn't be able to see it.
I opened the door. Goodness. Okay. For those of you in the chat, if you'd be so kind to leave a comment, that would be absolutely wonderful. There you go. I got you, but we're going to get started with today. Now, first and foremost, let me just give you a heads up so you can plan accordingly. For the intervention period. Obviously, we have that intervention period at noon till about 12:22-ish, something along those lines. Here's my goal for right now. We just finished up a post-assessment, which not everyone has taken just yet. I assigned that post-assessment at the end of last week, or we were supposed to take it in class, but I made the due date. Where is it? Boom, there it is. I made the due date for that post-assessment on Wednesday, the 26th. So I want to make sure that you can plan accordingly for this intervention period, which starts at noon today, where I am not going to be assigning you anything brand new and during this intervention period today. Instead, during this intervention period, starting at noon to 12:22, you can either work on that post-assessment if you haven't finished it already. Again, that's not due till Wednesday. Or if you would prefer to work on that Edge Elastic major, which not everyone has turned in, that would also be fantastic as well. So I'm not assigning anything brand new during the intervention period. Instead, you can use that time to catch up on what you need to catch up on for my class. That would be fantastic. In the meantime, I do have something that we are going to be working off of, something that we're going to be continuing with sequences and series. But what I need from you in order to do that, if you do not already have them out, I'm going to need those notebooks out and open. I'm also going to be passing out a worksheet to you guys. For those of you online, I have a PDF version that I'm going to post in a couple minutes. Let's see. Should be 3 in there. There. There's 3 in there. 2 in the back there. And I got 2 in there. Let's see here. For those that are, there we go. For those that are online today, the PDF that I'm going to be working off of, this is the PDF for today. I'm going to post that right there. Boom. Nope, not that one. Come on, you. Did I post the wrong one? Yeah, I posted the wrong one. Hold on. Delete that post and post the other one that I need. Let's see here. Upload to Drive. There it is. Okay. I got the right file here now. Let's try this. Add from file. Browse, upload to drive. There it is right there. Come on. PDF for today and post. This is what it should look like. This is what you guys should all have in your hand right now. If you are live in person, it is a two-sided worksheet, one that says 11.2 and the other side which says 11.3. On the 11.2 side of this worksheet, there are a bunch of problems in regards to arithmetic, sequences, and series. And on the 11.3 side of this worksheet, there are a bunch of problems in regards to geometric sequences and series. And my objective for today is to be able to practice these problems and to be able to answer depending upon what they're actually asking us to do. So if you would, regardless of if you're live or in the live chat, I would like you to go to the 11.2 side of this worksheet. That would be absolutely wonderful. I'm just trying to get the live chat open on my phone so I can answer questions if need be. That'd be great. And I would like to write down into my notes. Here we go. Let's start with problem number 5. Problem number 5. I'm going to flip over to my notes as well. There we go. Today is May 24th. And this is series and sequence practice. I should write that a little darker. Here we go. Series, sequence, practice. And like I said, I would like to write down number 5 on the 11.2 side of that worksheet. Now, in the directions for number 5, in the directions, they're asking for you to write a rule for the arithmetic sequence. Please, someone enlighten me. Why in the world, besides the directions, how in the world do you know that this is arithmetic? How can you identify this sequence as arithmetic? Clearly, it has a pattern, but just because it has a pattern doesn't mean anything. What type of pattern does it have?
It has a common difference that add or subtract in the same number each time.
But what is it? For this example, though, what is it?
Like what would it be?
Yeah.
Oh.
-7. Absolutely. It is arithmetic by the definition that she just read us. Absolutely. It is arithmetic because it adds or subtracts the same number every single time. Yes, they tell you in the directions it's arithmetic, but I wanted to make sure that we knew that as well. And more specifically, it is subtracting the same number every time, but we would express that as D equals -7. Absolutely. -7, -7, -7 every single time. Now, that is not the rule. That is not the rule. That is the pattern. There is a distinction between patterns and rules. Oh, Ms. Murray, it's -7 every time. Great. That's the pattern. But if I wanted the general rule, then I wanted a formula that could govern any term in this sequence. I would have a formula that would be able to get me any term in this sequence. So I'm going to turn to this particular formula, which is for the general rule of an arithmetic sequence. Now, again, you don't have to memorize that, but you need to know how to use it. A sub 1 is going to represent our first term. D obviously is our common difference. You can plug that information in exactly where it needs to go and then simplify. Simplifying would involve distributing that -7. You're going to have to distribute that thing correctly. Make sure that when you distribute it, you do make that a +7 inside the parentheses. Because being distributed, that's a negative times a negative. And then ultimately, I get my general rule of -7n plus 12. This is the general rule. This is the formula that governs the entire sequence, that determines any term within that sequence. The 5th term, the 10th term, the billionth term, it doesn't matter. That formula would be able to get it for you. But now, look at the rest of the directions for number 5. Look at the rest of the directions for number 5. Write a rule for the nth term of the arithmetic sequence, which we have right there, but then find a sub 20. They want the 20th term. Yes, I could literally just keep subtracting 7 until I got there. And the 20th term is not that bad to be able to keep subtracting 7, which I'll show you. But the more efficient way of getting the 20th term, the much more efficient way of getting the 20th term is utilizing that formula where you simply plug in a 20 and see what the heck happens. That should be what? Negative 140 plus 12. That should be negative 128. That is my 20th term. Now I'm going to zoom in on the calculator in a moment. I'm just going to leave that up there. But this is in general what you would have to do. They give you a limited amount of information, and then you have to go about answering the question that they set forth. It's insane. In fact, in just a few moments, I am going to be giving you a couple of problems, probably 3 problems, maybe 3, off of this particular worksheet to try on your own. One of them being a challenge. But let me zoom in on the calculator real quick and just get to that 20th term this way, just because, again, it's not that bad doing it this way. Minus 7. That's second. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's the 20th term. It's kind of tedious doing that, especially if you have to get like the 50th term or the 120th term. Instead, I just use the formula. So now here's what I want you to do. Here's what I would like you to do. I'm going to give you 3 problems. Yes, 3 problems to work on where you are going to follow those directions. I'm going to help you, well, kind of get the push to get started with these 3 problems, and then I'm going to give you a small block of time to knock them out. And then we can see where this is going to go. The 3 problems in question that I'm going to have you do, I'm going to write the numbers at the top right here. I'm going to have you do number 7. I am going to have you do number 12. And I am going to have you do number 15. Number 15 is the small challenge. Number 15 is the small challenge. If you feel so advantageous, you could jump straight to the challenge if you wanted to, but that is not a requirement. My objective right now is for you to definitely knock out 7 and 12. And if you feel so inclined, number 15 is waiting for you for a challenge. Now, to set this up, though, for number 7, they give you the sequence. And from the sequence, you can identify a first term and a common difference. And then eventually, I want that formula. For number 12, they give you the common difference, but they don't give you the first term. They don't give you the first term. Instead, they give you the 12th term. That's not going to help right now. I mean, that could help eventually, but I need the first term to be able to move forward with the formula. And then, like I said, with number 15 is the small challenge. If you can handle 7 and 12, then you're good. If you can handle number 15, then you know what you're doing with these problems. You definitely know what you're doing. But for number 15, they don't give you the first term. They don't give you the common difference. Instead, they give you the 7th term and they give you the 11th term and nothing else. Yet they all want the same thing. They all want you to write a rule, a general rule for the arithmetic sequence. So the time is 11:16 right now. I'm going to give you guys a small block of time to knock out definitely those two problems, and if you have time, that third problem. Let's get to work. Yeah.
The rule is just like difference, right?
The difference, like before when you said -7, that was the pattern. The pattern is just being like, oh, it's doing this every time. Like it's doing -7, -7, -7, but that's not the formula. That's not the general rule.
Oh, so like the rule is like
The actual equation.
actual
Yeah.
rule. So you mean like sequence or No,
All right. I learned a new insult. You can call someone a group of pandas. Do you know what a group of pandas are? Somebody Google it.
Oh, wait.
Google what is a group of pandas. I just look it up. I said it's an insult. I didn't call you guys a group of pandas. I just said it's an interesting new insult.
Mr. Joe, what is a group of pandas? What is a group of pandas called? Embarrassment?
There you go.
Found it.
That's a real thing, right? Isn't that messed up?
Embarrassment. Why did it take you so long to find it? Because it didn't say it in the first thing. It literally is in the
Yeah,
first
mine
sentence.
popped
There
up
are,
anyway.
there are a few different names for a group of pandas, including an embarrassment.
I did it in short, group and call it embarrassment.
Well, yeah, no, I had to click the link and I found it. Here it is.
Don't say that to him.
You're a group of pandas.
There you go.
Really? Well, guess what? What?
I think he's trying to look up something snide.
Uh-huh.
While he's doing that, I'm going to begin these problems.
Okay, I'm trying to give you a group of sloths.
Okay. So back to this. I'm looking at this problem. I'm looking at number 7. First thing that we need to be able to identify for number 7, the first term is a given. We know it's 2. And the common difference is as easy as just, well, it goes plus 7, plus 7, plus 7. The common difference is 7. Knowing those two pieces of information, all I would have to do is then plug that in to this formula, simplify that stuff down. Well, that a sub 1 actually should be a 2. There we go. 2 plus 7n minus 7. The general rule should be 7n minus 5. Should just be 7n minus 5. Or a sub n equals 7n minus 5. Now, if you were to find the 20th term, you just plug a 20 in, and then you would have it. But that's not the purpose of these problems that I gave you. I wanted the general rule for each of them. Just for the sake of argument, if you want the 20th rule, 7 times 20 is what? 140 minus 5 is 135. Number 12. Now, with number 12, it's slightly more difficult because they didn't give you the first term. They gave you the 12th term. There's a number of different ways to do number 12, but let me show you, in my opinion, one of the more straightforward ways. The most straightforward way to go about number 12 is by utilizing the exact same formula that we just used before. But we're using it to find, and look where the pencil is pointing, we're using it to find a sub 1. That would be my objective. So instead of a sub n, I'd put in a sub 12. A sub 1, I don't know what a sub 1 is, plus parentheses 12 minus 1 times 2. I would put a 12 in for the n because it was a sub 12 that I'm trying to find. Now, the interesting thing is, a sub 12, I know what a sub 12 actually is. A sub 12 is equal to 18. And because of that, I can now find the following. I think we've done a problem very similar to this, if not this problem before. Because I did 12 minus 1, which was 11, and then 11 times 2 is 22. A sub 1 should be equal to negative 4. Knowing that now a sub 1 is equal to negative 4, now we can actually proceed with the problem. Now we can actually move forward using the common difference and that general rule a sub n equals -4 plus parentheses n minus 1 times 2, and then I can simplify that thing down. The only thing for number 12 is that it was this extra little step. It was this extra step of needing to find that first term in order to eventually get to the final answer, which is the general rule. So everything to the right, everything on the right side is stuff that we've done over and over again. The stuff to the left, I've shown you how to do that in the past, but it is an extra step to be able to get a sub 1. Yes, you could just count backwards from the 12th term if you wanted to. You could just count backwards to the 11th, 10th, 9th, 8th, all the way down to the first term by doing the opposite of +2, which is -2. But sometimes that's not feasible. $15. I said 15 was a small challenge. If you got through the first two, then you're good. If you got through 7 and 12, then you should be fine. 15 is a bit more of a challenge. The reason why 15 is a challenge, they don't give you anything, really. They don't give you a first term. They don't give you a common difference. But they expect you to be able to solve this thing, getting the general rule. I'm going to write something down for this problem that I want you to write down as well, kind of as a reminder. What type of equation are arithmetic sequences? What type of equation? The name of an equation that you have learned in the past, the name of an equation that you've been learning pretty much since middle school. What type of equation are arithmetic sequences? Look at the general rule that we got for number 7. Look at the general rule that we got for number 12. What form of an equation do they appear to be in? Cricket, cricket. I hear crickets. What form of an equation do they appear to be in? 7n minus 5, 2n minus 6. Instead of n, what if I said 7x minus 5 or 2x minus 6? What was the main objective of Algebra 1? What type of equations were you graphing and solving and doing all sorts of weird things with? Systems of, ugh. Oh, Mr. Markey, none of us want to talk because half of us aren't even paying attention to what you're saying. Oh, that's the truth, Mr. Markey. Half of us aren't. I know. It's that time of year. It's May 24th. It's like 1,000,000 degrees in here. I know, it's not that bad. Yeah.
I'm cold over here.
You don't clap for yourself.
I do.
This was a sarcastic slow clap.
Okay, well, I'm happy for myself.
Ah, group of pandas. Linear. Ladies and gentlemen, you need to know that arithmetic sequences are nothing more than linear. They are linear. If they are linear, a lot of consequences come with that. If they're linear, that means that we can actually use this information that they gave us in number 15. We can use this information and actually do the following. What the heck am I doing right now? I'm using the numbers that they gave me. I'm using the numbers that they gave me in number 15, but I'm putting them into this weird looking fraction thing. What am I actually doing? What am I actually calculating? It has to do with linear equations. What is it? Yeah, it's slope. I didn't teach you slope. Algebra 1, okay, now I'm going to put this in quotes. Algebra 1 taught you guys slope. I think it's fair to put it in quotes. Is that fair? Yeah. Algebra 1 taught you slope. I think pre-algebra. Did you learn in pre-algebra too? 8th grade? Okay. But if arithmetic sequences are linear, that means that we can treat these like ordered pairs. This is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's what this thing is. Because if I were to do this correctly, well, negative 34 minus negative 22 gives me a negative 12. Negative 12 over positive 4 spits out a negative 3. And you said slope, but I'm not going to label it as slope. I'm going to label this as my common difference. I'm going to label that as my common difference. That is the pattern by which the sequence would progress. It goes minus 3, minus 3, minus 3, all the way down the line. That can be found if you have two ordered pairs, or in this case, two terms from the sequence. Arithmetic sequences are nothing more than linear. And because of that, we can now proceed with finding my first term. This is the same process that we just went through with the previous problem. I can find a sub 7 by plugging it into the following formula. I have all of this information. I know what a sub 7 is. A sub 7 was given to me as a negative 22. I can multiply together the 7 minus 1 times negative 3, gives me negative 18. And ultimately, I can find my first term is negative 4. All of this are just extra little steps that need to be taken. Extra little steps that need to be taken along the way with these problems. Just weird looking things. From there, I can plug this junk in and ultimately get my general rule. If I distribute this 3 correctly, this negative 3, the proper math should work out. And I get my general rule. It's a linear equation. Now, I'm going to leave this up here, but I'm going to give you a little bit of a warning. There is a topic on this worksheet, on this very worksheet that I gave to you, that I am not going to teach you per se. There is a topic on this worksheet with a certain type of problem that I am going to bypass simply because of the amount of work that is needed to get it done. I want to stick to the linear aspect of arithmetic sequences. I want to stick to the linear aspect of it and nothing but the linear aspect of it. You can find a slope. You can plug that thing back in. You can get that first term. You can go back and get the general rule. It's all linear, linear, linear. But there is a messed up question that I could ask, which would eventually turn this thing into quadratics. And I don't want to do that particular part of it. I give that whole speech because let's take a look at something like number 22. Let's take a look at number 22. Now, like I said, with number 22, I'm not doing the quadratic portion. I'm only going to stick with part A. I'm only going to stick with part A. So with number 22, we're going to do this one together, but we are only going to do part A. If you were to do part B, then that would lead you down a quadratic path. And I don't want to do that for this particular chapter. So I'm going to write down number 22, but be forewarned that we are only doing part A. This marker. It didn't make it. Number 22, part A, n equals 15. I'm sorry, n equals 30. I was looking at the wrong one. N equals 30. 32, 24, 16, 8, 0, ... They want me to add up the first 30 terms. You need a formula. The formula that you need is this. Please make sure you're writing this down once again, because it's always good to have this formula written every time you use it. It helps you get used to it. It helps you understand the components behind it. It normalizes it, so to speak. For number 22, they want you to add up the first 30 terms. Now, they only gave me 5 of the terms. I could keep going if I wanted to and actually list out all 30 terms, but I don't feel like doing that. Instead, I'm going to use this formula. I need to plug in this information. What pieces of information do I need? This question is for all of you. What pieces of information do I need in order to actually utilize this formula? I have a couple of them right now. But what do I need to actually use this formula? Starting number. A sub 1 is 32. Got it? What else? Eventually, maybe, but for this formula, I mean, it doesn't exactly look like it. I mean, I know the common difference is what, -8? Yeah, maybe that will come in handy later. I mean, definitely the starting number, but definitely the first term right there, a sub 1, which we know is 32, which we'll plug in later. I do have n. N definitely equals 30. Which, let me plug in what I got so far. Because there is one more thing that I need, that you need to identify. There is one more thing that I need. But let's plug in what I have so far. You told me that n is equal to 30, so I'm finding the sum of the first 30 terms. N is equal to 30, so I put a 30 in right there as well. Parentheses. A sub 1 is equal to 32, so I plug a 32 in right there. Plus, it says A sub n, so I'm putting in an A sub 30, because again, n is equal to 30. The whole thing is over 2. Those pieces of information you just gave me. You said you have the first term, so I plugged it in. You said I have the n value, so I plugged it in 3 different locations because I'm finding the sum of the first 30 terms. There is the value of n in the formula. And there is a sub 30 instead of a sub n. I need one more piece of information. I need one more piece of information before I can actually wrap this problem up. What is it? Well, I'd keep them together. I need the a sub 30. I need the 30th term. This is where the common difference will come into play.
Is that when you need the other equation?
Yes. Yes. Just to recap what you just said. He asked, is this where you need to use that other formula? The a sub n, I'll write it out, a sub n equals a sub 1 plus parentheses n minus 1 times d. Is this where you have to use this formula to get the 30th term? Answer, yes. It's a lot nicer than we think, though. To find the 30th term, I'm going to be plugging in the first term. I'm going to plug a 30 in for this n right here. And we just decided before that the common difference was -8. We decided, well, we knew the common difference was -8. We saw that within the problem itself. If you do that calculation correctly, which I'm just literally going to type it in as is. Boom. -200. That's the number that has to go for a sub 30. This number right here is actually -200. This is just where you guys would calculate it. Just knock that whole thing out. 32 plus -200 divided by 2 times 30. It spits out the answer. -2520. That's all that I'm really going to be asking of you with these problems. That's all that I'm really going to be asking of you with these problems. I just have to make sure you know how to do that particular portion. Part B, I am not going to have you do. Part B on that problem would eventually require you to solve a quadratic. You would actually create a quadratic based on this formula, and it is very convoluted. So I'm going to bypass that. Instead, I'm going to teach you a little tiny something about Greek. You guys know Greek letters, right? Name a Greek letter.
R.
R is an English letter.
I know what Greek is, but I don't know.
You know a Greek letter. You could name any fraternity, sorority.
It's like this delta.
Omega.
Yes. Delta, omega, alpha, beta, gamma.
Oh.
Yeah.
It's kind of like the military alphabet.
So yeah, absolutely. Kind of. I mean, to an extent. Because the Greek alphabet's actually shorter than the English alphabet. You know a Greek
24 letters or something like that.
something like that. You know a Greek letter that actually doubles as a number. Pi. Pi is a Greek letter. Yes. I have to teach you one Greek letter. Just one. Just one. And it's actually on number 23, 24, and 25 of that particular worksheet. You guys know what that symbol is? This one right here.
Oh, the E.
It's not an E.
Well, it's like a.
It's not an M. You may have seen that on, like, fraternity, sorority things.
Yeah.
You know?
What letter is it? Is it a Z? Like
Nope.
Delta, whatever.
The English.
They use it as an E.
No, not exactly. The English equivalent. By the way, the E in the Greek alphabet, the E equivalent is epsilon. Yes. Epsilon is the E equivalent, but this is not that. This is actually the S equivalent. This is actually the S equivalent. This is the Greek letter sigma. This is the Greek letter sigma.
Oh, Sigma Pi.
Exactly.
I know that one.
Yeah.
My sister's in China, so I know Sigma Pi.
Well, that's what I'm saying. This is the Greek letter sigma, though. Also, did you know that there are different variations of capital and lowercase Greek letters, too? For example, pi. The pi that you know is actually the lowercase version.
What's the uppercase?
The uppercase version looks exactly the same, except it's bigger, like this one. And instead, you know how pi usually has the squiggle? It's just a flat, straight line. Yeah, capital pi means something completely different. Yeah.
Makes sense.
Sigma translates to the phrase, the sum of. It translates to the phrase, the sum of. This is why they're using it on this particular page. It means the sum of. Do you guys know how they have like the names for hurricanes and stuff like that?
Like Hurricane Irma.
Well, they have the names picked out years in advance. Did you know that? Yeah. And then if a hurricane becomes infamous, then they retire the name and they never use it again. You know, so in the Atlantic Ocean, for example, when Hurricane Sandy hit, that will forever be the last Hurricane Sandy you will ever know of. There will never be another Hurricane Sandy in the Atlantic Ocean.
What was the worst hurricane that ever hit?
Probably Katrina.
Hurricane Katrina was on the thing.
Hurricane Katrina was at 2005. Hit the.
Is that Hurricane Katrina or Hurricane Irene?
There wasn't Irene, but no, Irene was 2011, and that wasn't as bad.
That one was on my birthday.
Okay, Hurricane Katrina was in the Gulf Coast through Louisiana, decimated New Orleans.
Yeah.
You know, people like they had people like lost their homes and were camping out in the Superdome. It was bad. But my point being is there'll never be another Hurricane Katrina because they retired the name. Now, every year they have a certain number of hurricane names picked out, and they go through them alphabetically. But do you know what happens if they have too many hurricanes? If there are more hurricanes than they have names for, you know what happens? I know, right?
They make more names.
No, they don't, because those names have to be approved in advance. They have to be approved in advance. Watch, 2006
Easily make a Hurricane Matilda.
Atlantic
Send it out there.
hurricane season. No, they have to have them approved in advance. So, like for example, in 2006, I'll bring you down to the names here. There's Ernesto, Florence, Gordon, Helene, Isaac. Oh no, maybe it was 2005. Yeah, I think it was 2005. Maybe that was the Katrina season. Oh yeah, there it is. Yep, there's Katrina, Hurricane Katrina, 2005. That one's messed up. But watch what happened when they ran out of names. Tammy, Vince, Wilma, Alpha, Beta, Gamma, Delta, Epsilon, Zeta. It just kept going. They use Greek letters.
Okay.
It's insane. It's what they do. But then, like I said, eventually, you know, names are recycled every like generation or so if it's not notorious. For example, when I was a kid, the biggest hurricane to hit the United States when I was a kid was Hurricane Andrew. It hit Florida. It went right over the peninsula. Billions of dollars worth of damage in 1993.
Did you ever have Vine?
No, I didn't.
No, well, there's this funny video. It's like,
No, thank you right now. Yeah, Hurricane Katrina killed a lot of people. Anyway, okay, fantastic. No, actually, I asked my mom once because she grew up in Puerto Rico. I asked her actually after Hurricane Sandy hit and we were without power for like a few days. I'm like, Mom, do you remember when you were a kid if like hurricanes hitting the island of Puerto Rico? Like, and she's like, very casually, oh yeah, like at least, you know, once a year the roof got ripped off and we had to replace it. And you got to think, my mom grew up in Puerto Rico. The type of roof that they had was like, you know, those villages where they're like corrugated steel. Yeah, that's the kind of house she lived in, you know. But yeah, at least once a year the roof would get ripped off.
Sound when it rains is probably bomb.
Yeah, she's complained about that.
Complain, that'd be awesome. Fall asleep.
Yeah, not if you have to live there all the time. Okay, back to this. So the reason why I bring all this up is because of the following. In the example for number 23, we're not actually going to find the sum of at the moment, but I want to write this thing out. I want to show you what each of these things actually do. So for number 23, they give you the following notation. And what this is actually asking you to do, it's asking for you to find the sum of that particular sequence, starting with the first term and ending with the 25th term. So for example, if I wanted to find the first term, I would plug in a 1. I'd plug in a 1. 2 minus 7 would give me -5. If I wanted to find the 25th term, I would plug in a 25. 2 minus 7 times 25 gives me negative 173. This sequence starts at negative 5. It goes minus 7, minus 7, minus 7, minus 7, all the way down to negative 173 at the 25th term. And they want you to find the sum of those 25 numbers. That's what they're actually asking you to do for this particular problem. So this problem, knowing those pieces of information, is really asking you to do the following calculation, which I would have you write down, and then I'm going to tell you what the actual thing calculates out to be. It's asking for you to use the formula that we have been using this entire time, where you take n times a sub 1 plus a sub 25, the first term plus the last term, divided by 2. And it knocks that whole thing out. It equals negative 2,225. So whenever you see that sigma, first of all, note to yourself that it's asking for you to find the sum of something. That's what you need to recognize right off the bat. Second, whatever formula is here, now in this case, this was an arithmetic formula. You can tell it's arithmetic because it looks linear. It's asking for you, oh, there's the first term. They want you to plug in a 1. And there's the last term. They want you to plug in a 25. Well, if that's the first and the last term, I have those terms for the formula. That's all that I really need to worry about. For geometric, it gets a little trickier. But for geometric, we're going to worry about those on Wednesday. That's the back of this worksheet. So on Wednesday, we will be knocking out some things on the back of this worksheet, getting more practice with geometric, and then we'll see where it takes us. Now, the time is 11:52. We're about to enter the intervention period of this class. And as I said at the beginning, I am not assigning you anything brand new for this class period. Instead, I'm going to remind you of the things that we have outstanding that you need to get done. First, just kind of going through these. If you go on Google Classroom, you will see what you owe me. There's a post-assessment, which is due tomorrow. There was a rationals major on Edge Elastic, which during this intervention period, I am going to be updating the grades for that chapter test. I am going to be updating the grades during this class period. I got to go through some things, and then I'll be able to update it before you leave. And of course, there is that previous enrichment, the enrichment from May 14th, if you did not get that thing done. I would highly recommend that you take advantage of this intervention period and use it to get some things done to catch up on late work. That would be fantastic. For those of you in the live chat, I will have the live chat open at my desk over there so that if you do have a question, I will be able to answer it in real time. And of course, if you have not left a comment, please make sure that you do so. That would be fantastic. All right. You have until 12:22. It's really funny. I feel like this class, more than anything, has just generally accepted the fact that I just casually mentioned my mom growing up on Puerto Rico. And you're like, yeah, that sounds legit. I know. I'm just saying, other classes in the past, even though I've told them multiple times, in the past, they'd be just like, Puerto Rico? Yeah, right. I'm like, yeah, I told you in the beginning of the year. And they're like, I thought you were joking.
Well, I mean, you don't really look.
I know. I'm half.
What's your other half?
Irish.
Yeah, definitely.
I know.
Did your mother like yell at you in Spanish?
All the time. Yeah.
Are you good at Spanish?
No. See, the thing is, my mom, she married an Irish Catholic guy from Brooklyn. And in Brooklyn, she married him in the early 70s. In Brooklyn, during like the 60s and 70s, it wasn't, let's put it this way. It would have been frowned upon for my older sister specifically for, young Irish Catholic girls to be bilingual during the 1970s in that particular part of Brooklyn.
It was.
You know.
Be bilingual.
Say again?
Why would it be bilingual?
I mean, it'd be fantastic if I was bilingual. It would be. My mom is bilingual.
Wait, people.
It would have been frowned upon if you had these little Irish Catholic kids, speaking Spanish.
Yeah, I mean, but like, it's always good to learn.
Absolutely. I agree. Now, it would, I'm sorry, anytime it would be great to learn. I'm just saying back then it was very much frowned upon. It is really messed up.
That's kind of weird.
I know. Well, my mom actually has a twin sister. My mom has a twin sister who married a Puerto Rican guy, and all of their kids speak fluent Spanish. So I have a lot of cousins actually who speak fluent Spanish, and I don't.
Meetings must be fun.
They kind of are. Yeah. I mean, we stick out like sore thumbs. We really do. It's insane.
I have some Spanish in my family. They stick out.
Yeah.
And it's really funny because my uncle who's Spanish and makes comments on it all the time.
I really should find some like pictures on Facebook of just like some of my cousins, because like these are like first cousins, and like how are we related?
I have, I think, is that 3 or 4 cousins from Colombia? What? Yeah. Whose side? My mom's.
Here you go. Hold on, I'll bring it up on the.
My mom's sister married a Colombian dude.
Hold on, let me flip this over. This is my cousin Carmen. Right here. This is my first cousin. I'm just saying.
Wow.
How is that even possible?
Yeah, that is not.
Yeah, that's my first cousin, Caddy Lou.
What's funny is my boyfriend's uncles, they all look different because his dad, his grandfather was like kind of a fighter, and so he went from country to country to country. So
That's not us,
there's,
by the way. Yeah.
He's like 7 uncles, like one's in Switzerland, he has an aunt in Jamaica, and he has another uncle like in Cuba.
Nice.
They're all over.
That's my cousin Jose. Yeah, I'm just saying. I'm like, how in the world? Like first cousins.
I see it a little bit, like,
You know?
kinda look like
No, I
No,
don't see
it's just
anything.
it looks like you, but it's like
Hold on. Let me see if I can find my Uncle Ray.
The eyes and the nose.
See if I can find my. Oh, hold on. Here's my my mom's twin sister. My mom's twin sister and her husband,
Oh my god.
my Uncle Joe.
Oh,
Yeah.
That's your mom?
No, that's my mom's twin sister. See the name at the bottom?
Or even either.
Oh, I'm just saying. Yeah, that's my mom's twin.
Is it black and white?
I don't know.
'Cause she doesn't really look that Spanish.
I know it's probably because it is in black and white. I mean, we're not that tan. I'm trying to find a picture of my Uncle Ray. My Uncle Ray is like the quintessential like Puerto Rican guy. There he is. That's my Uncle Ray right there.
He looks more Italian.
I know, but he's not.
What are you with?
Look at the name at the bottom.
oh my god.
Yeah, in the
Like Hispanic people usually they take their middle, like they don't have middle names. It's like where they grew up.
they take the mom and dad's name.
Although like
Yeah.
my friend's mom, like she's like the town in Costa Rica where she like was born.
Oh, really?
So she's like, oh, I have a middle name. It's like the town where I was born, like in that area. This is what they do. Like,
Okay.
Everyone is like has the same middle name.
Well, my mom's maiden name is Ertha Marie Colon La Torre, and Colon La Torre. Colon is the name that she got from her dad's side, and La Torre is the name that she got from her mom's side. You know.
I'm not Joseph.
Did you even believe? Like I have 24 first cousins, just alone first cousins, not counting who they married and how many kids they had.
I have
Yeah.
7.
And growing up, all 24 first cousins growing up all lived within a half an hour of each other. Yeah. From Jackson, Waretown, Pemberton. Yeah. Anyway, back to work. What?
I have 6 first cousins.
All my, like,
And they're
all my
all
cousins
old.
are close in age, like they're all 30, and then I'm looking, well.
This will be the last thing I say, I promise. 'Cause I can talk about this all day, but I do have to get the work done because I want to make sure I get the edge elastic grades up to Genesis. 24 first cousins. I'm the second youngest,
Really?
and I'm 37. The oldest is in his mid 50s.
Yeah.
We are spread out. Even though my mom and her siblings are all within 6 years of each other. Yeah, my grandmother had 6 kids before the age of 23. Yeah.
Wow.
That's how they did it back then. To be fair, it was 5 pregnancies because one of them was twins.
Yeah.
You know? So like you guys are what, 16, 17, 18 years old?
Yeah.
Something like that. By the time my grandmother was 18, she had 4 kids.
My closest relative
That's
is
getting
23.
closer to though.
Say again?
Like a lot of mothers are like 16.
Yeah, she was 16. Yeah. Here we go. Just as a side note, for those of you that, for the Edge Elastic major, for the ones that have been submitted, of course, I'm going to do the grades for those. For the ones that haven't been submitted and that I can clearly see are in progress, yes, they're late, but they will be graded for something, but I'm not going to put in a grade right now. I'll just put it in as missing for the time being. Okay. Okay. What was the answer?
just saw you submitted the grade.
Yeah.
Do you know what question I got wrong?
Yes. Let me see here. That one.
I thought it was that one. That one I had no clue what to do.
I gotcha. And then that one.
Okay.
Let me double check that. Oh, I think I know what that answer was. Hold on. Let me just double check something real quick. Yeah, this is what the number should have been.
Okay.
And then, yeah, that was it.
All right.
Yeah. All right. And that's the day. Make sure you're getting that stuff into me. There's the bell. If you haven't left a comment in the chat, please make sure that you do so. I will leave this open for just another extra few moments just in case.